any questions on this, please ask me. I don't grade the quizzes. I used to, I mean, when they are in class, but I don't grade the online one. So Shi Hong looks through them and I asked her to take off points based on this. So does anyone have any questions about the quiz?
For the candidate keys there, you have year listed as well, but wouldn't year not be a unique value?
Isn't it unique? Yeah, it is unique. Year is unique. You have.
It's unique in this instance, but I mean, if you added other things, unless you enforce that you could only have one project per year.
Yeah, so you have to answer the question based on the instance that I gave out here.
Oh, okay, okay, that
So,
makes sense.
yes,
Yeah, I
that's
was
the
confused on
reason.
that too.
Yeah, because I had written in mine, I was like, oh, it's only this, I only see one that potentially could be it, but I get it now.
Yeah, because even something like P name and all, it's unless you specify something in the schema, you won't really know, because you could have two projects with the same name too.
That's
So,
true.
yeah, so you just had to answer based in context of what's given on the quiz.
Okay.
And then for question number 5, I can't remember whether the tool, relational algebra tool, actually lists null or doesn't list null. So null is really more a database thing. It's not so much a set theory, because in set theory, you don't really hear about null. So so I wasn't sure. So whether if whether you put null or didn't put null, I wasn't going to take off points for that. And in the last part where it's not, question number 6, dname not equal to CS. So that's the thing about null, is that I mentioned null is, I mean, typically you would have put health also in there. But like I said in class, null is kind of a special kind of value. It's just states that I haven't entered the value right now. So there might be you can't really make any assumptions. So if you give a query like this, you won't get health in there, only robotics will be there. Um, and again, the tool, because relation set theory by itself does not really deal with null. I'm not really sure how the tool deals with it, but the tool is built on top of SQLite, so it should give you this correct answer too. So.
Just another quick question. For the candidate keys, or sorry, for number 4, is the one listed there P name or D name? I'm having trouble reading it.
That's P name.
Okay, thank you.
P name. Oh, it's P name. You can't have D name because it's got null. So that's one of the things with key. A key can never have a null value in there. So you can't have D name out there. It has to be P name. Yeah, and also for the assignment, for some of the queries and assignments, you might have to enter values of your own. And you can just, if you look at the .ra file, those are all SQL statements. You just have to add a SQL statement in there. So I couldn't remember whether I had given you, just the .db file or the RA file. So now I'm giving you the RA file. In the old days, the SQL tool was a bit different before. So it used to be a JSON file before. So that I never used to give to students. I would compile it and get the .db file. But now he changed it in the last version, which is really convenient. So if you want to add data or remove data, you can do that in the .ra file. So if there are no other questions, I'm going to continue with the relational algebra. So, so list names of dependents of female employees. So I left it out here. So you could write it down as, sometimes this works fine. Okay, so yeah, I don't remember whether and was, so you can just write it as and. I think that's anyway the way you write it in the tool. So I think and was like this. Um, so now the thing is that sex, if you look at the table, let me just bring up the table also, the company table. Okay, so if you look at the sex field, it's the same in both employee and independent. So if you say sex is equal to sex, you'll get an error because it doesn't know what sex you're talking about. So you'll have to write down so you can just write employee.sex. You'll write the whole name employee. I don't have space to write it all down. So employee.sex is equal to dependent.sex. And then you can employee cross product dependent. So that's how you list the names of dependents or female employees. And again, at this point, you can write the same thing in many different ways. So another way of doing this would be, you could have written it down as oh, sorry, I did a mistake out. It was female dependents, but I don't know why I wrote this down. That must have confused everyone. Just realized that. Okay, so you could, write it down in this manner too. Just 1 second, I did. To be careful of some of these queries, you have to really pay attention. I wasn't paying that much attention. This is employees, it should be this. So sigma sex is equal to female employee by SSN. So there should be another parenthesis out there. Let me just write this properly. Actually, it's difficult to write when I open both. Okay. And then okay, I think I got them all right now. So I hope I didn't confuse you all, but does this make sense? You could have written, my point here was that either you could have written it the way it was up here, in one shot, or, you can break up. You can first find out the female employees in the employee table, and then you can just get the SSN column out of that. And then you do a cross product with dependent, and then you do the equality. So both of these are equivalent. So So do you have any questions? I hope I didn't confuse you, because all these parentheses, when you do it in the tool, it'll give you an error. But when I write, I've got to be just careful with it. So do you understand? Do you have any questions on this? Okay, so then let me do this next query. I'm just going to open it back up. I'm finding sometimes difficult to write with. Okay, so. Okay, so then this next query. Okay, list the name and social security number of employees who are supervisors. So I would like you to try this out. So, and I'll do a smaller table actually for this one too. So while you are writing it out, let me just write a smaller table. Okay, I hope you've at least able to write, attempted to write down this query. So in this case, you're really looking at only one table, the employee table. So the fields that are relevant in the employee table are the social security number, the name, and the supervisor's social security number. So from that emp table, you have to list out just the supervisor's name and the social security number. Okay, so the thing out here is that you cannot just, you have to use a cross product in this case, because you can't just print 5678 and Mary, because 5678 is Anne, it's not Mary. So you can't just use a single table, you have to do a cross product. So I'm going to do a cross product of the employee table with itself and just show that to you. So we have, so I'm going to do just a cross product, and so this is because I'm calling it SSSN, supervisor social security number. Okay, so I'm going to do a cross product of EMP with just the supervisor social security number. So we have the following fields. Okay, so. Okay, so I'm going to write down this whole table. I'm doing it not so much for this query, but for the query that I'm going to do next. So in that case, you need to look at this table in to be able to kind of really get the next query. So I'm going to write down the whole query. Write down the whole table right now. And the null is not going to appear here. So we have. Okay, so this is the entire cross product when you cross product employee with employee. I just taken out one field. So what we need is we want to print out the supervisor's name and the supervisor's social security number. So, so therefore, what is the equality condition that we're going to look for out here? Anyone? Like, so when you do a cross product, what is the equality condition? Does anyone want to try? You look at this table, you can see this table and figure out what is the equality condition.
You're looking for your SSN is equal to the super SSN.
Yes, you're looking for SSN is equal to super. So those will be just this field. You have this one where you have supervisor equal to 1, and then you have this one. So these are the only two places where social security number is equal to. So that's the output of this would be. The query is going to be. I think I got all the parentheses. 1, 2, 3, 10, 3, 4. Okay. Okay, so do you understand? Does this make sense? Do you understand the query? Because, when you do the same table, sometimes it's a bit confusing. That's why I wanted to open it out and just show it. So does anyone have any questions? Did you understand this? Okay, so now I'm going to, like I said, let me do the next query, which is also related to this query. So this one was the name and social security number of employees who are supervisors. So the next one is just the reverse of that. List the names and social security number of employees who are not supervisors. Okay, so now I want to list who are not supervisors. So I want to list Mary and Joe because they're not supervisors. So one way of doing it, let me just write this down. So let's say, so here I've written SSN is equal to SSN. So why don't I just write it down in this manner? So I write so sigma SSN is not equal to, I think not equal to, by the way, when you do it in relation, it's written like this. Just, so I'll write it, but I'll write it down as not equal to out here. So, so do you think this is going to work? If I just would this give me the correct answer? What would be the output of this one?
Is that all employees who don't supervise themselves?
Yeah.
SSN not equal to, so you're saying that all employees who don't supervise themselves. So what would be the output for this one, for this particular table then?
Everyone.
Yes, it's everyone, because you look at every row in this one is SSN is not equal to SSN. So if you look at this particular table, any row you look, so here SSN is not equal to, so this will come in. This will come in. Sorry. This would be there. So pretty much every, so it's going to list all it's going to list all the 4 occupants. So this is not the correct way of doing this query. So the so the way of doing this one, if you wanted to do one way of doing this query is, so let's set A be equal to SSN of supervisors. So the way you would write that is, okay, so set A is just pi or supervisor, project supervisor out of the employee table. And let's set B be all social security numbers. So that would be just, so the set B minus A is the social security number of employees who so B minus A is a social security number of employees who are not supervisors. So, so that would be, if you look at B minus A, you would do should be the other way around. So this part, just put this part out here. So I just write B minus, because set A. So just or did I do the reverse again? Okay, so now you have the social security number of employees who are not supervisors. So then you can do the cross product with this one. So you have, then you do, so put this out here. Okay, so that's how you would do this query. So, so you can't do it like this. You'd have to do it like this. Okay, so do you understand? Does anyone have any questions on this particular query? So the queries, they do get a little complicated as you keep going, but you can do it in steps. When it looks complicated, do it in steps. Even in the relational algebra tool, do it in steps. It's a lot easier. Okay, so this was, okay, so I want to do a few more examples with cross product. Okay, so we have, okay, so list the department number, department name, and department location. So can you write down this? This is a rather easy query. So can you write this down? This. So you're looking at the department table. You're looking at these two tables. Okay, so the only thing out here you have to remember is because the names were all identical. So you had to state, to which table everything belongs by using the dot. Okay, so let's look at the next query. Okay, so list the first name of employee along with first name of his or her supervisor. So again, out here, you're only looking at the employee table. So, so I just want you to see if you can do this query. Okay, so when you have the same name for, because you're using employee and employee, a good way to start up is otherwise very confusing to think of it. So call the employee table, just have it, so call it E and call it, because you have on one end, you're going to deal with the supervisor's name. So so you have E, otherwise there's no way of differentiating. So rename the one table as E and the same table again as S. So the S will always deal. So let's say you're going to take out the supervisor from the S table. Okay, so I hope like you've had a chance to attempt doing it. So here you want to list, so what is the equality condition that we're going to look at? So we have, so you want to list the Mary, and Mary's supervisor is Anne. So the equality condition out here is you're going to look at the E.supervisor key. So So again, out here you have 8888, and this is connecting to Jack here. So just 1 second. So you have E.name and S.name. So that's a supervisor name. And then, so this is the most important thing is the condition, the quality condition. What are you mapping it on? So it's the E.supervisor field. You map it to S.social security number field. And then okay, does this make sense? Do you understand the query? Okay, so do you have any questions on do you understand how cross product is working? Because I'm going to move on to the next operator. I just want to make sure you understood this. And again, when you use the same table, sometimes it's a bit confusing. So, sometimes it's helpful to write a small table and do a cross product and look at the output and work it out. So this was it about the cross product. So I'm going to move on to the next operator, which is join. And you cannot understand join if you don't understand the cross product. So that's why I did the cross product first, to make sure you understood it. So, so again, from the textbook, I should say I'm doing chapter 8 right now. And it's 8.3. I've also been putting up PowerPoint slides, and those are just directly from the textbook. This is the new edition, and if you have the old edition, it's chapter 6. I'm not really sure why they moved it, but I think they moved some chapters, backward and forward. They didn't mixed it up. Okay, so join. So I do want to say so join is just a combination of the cross product and the select operator. So it's so join is written. It should be both. So yes, it's more. So that's the join. It's like a bow tie. So, and it's a cross product followed by sigma. So it's actually much easier to do than the cross product, because it combines both those operators. Because how often do you every query, when you do with a cross product, there's always some kind of select operator connected with it, because otherwise you're just getting this huge table that just crosses all the rows together. So join just puts them both together. So I'll just do pretty much all the queries that we did until now using cross product. I'll just do them with the join operator. So suppose I want to list I guess I didn't do this one with the cross, list the project name along with the department name. Okay, so that's you're looking at, so this is a project table. So here you have the project number and you also have the department number out there. So what you want is a department name. So you're kind of joining these two tables. And the field on which you're joining is the department number. You're going to join with this department number. So that's what you're really joining. So, so if you did this with the cross product, this is the way you'd be doing the query. Okay, so that's how you would be doing the query using the cross product. So using the join, it's a lot easier. You just have to say, that's it. So you just have to write down the join operator and then just say D number is equal to D number. So you don't have to do the, two different operators. You just have to use one. So it's a lot easier. And if I do the diagram, the tree diagram that we did earlier. So if you did it with a cross product, this is what it looks like. So if I was doing this part, that would be the pi operator followed by the sigma, D number, then D table, and then you have the P table. So that is the way you do it. But if you do it using the join, you're kind of removing one operator from the whole thing. So here it would be so you're just removing one step. So it's a little shorter. That's the main thing. So it is definitely easier to use than the cross product. So I just want to show some of the notation because this comes under different, there are different notations for the join. So I just want to put it down. So in the textbook, and there are different types of joins too. So just doesn't come out properly. Yeah. So in the textbook, if you just write a join by itself, and I'll show you some queries where you don't even, you don't have to even show the equality condition. So in the textbook, those are called, when you see the simple star symbol, that's equivalent to just this bow tie by itself. And this is called the natural join. Then you have, this can equal to, that's called the equijoin. And that's the same in the textbook. And then you have where you can have less than, you can have greater than, you can either do equal to, or you can do not equal to. So that is called a theta join in the textbook. Okay, so the different kinds of joins. So if you see the symbol, that just means the natural join. The rest are, you can, I think this is the only one that's a bit confusing because it looks different. All the others are pretty much the same. So let me give you some examples with a natural join. Okay, so I'll just go back to the same query out here. Which one was it? Yes. List the department number. Oh, sorry. List the department number, department name, and department location. So if you look at this query out here, it is rather unwieldy. It looks like very clunky and cumbersome. So you can write it very cleanly with a pretty clean code using the join, the equi-join operator. So let's do this. Okay, so you can write this down as so that's all you need to do if you're using the equi-join. So what happens on the equi-join is that, so if this is the department table, so what I did is I took out D name and D number from the department table. So I'm only looking at these two, and then I'm joining it with this one. So what it does in the natural join is that it looks at the attribute that has the same name. So it's D number out here and it's D number out here. So it does an equality out there. So what it is doing is it does department.d number equal to department location.d number. So it's doing that and printing it out. So you don't even have to, even when attributes have exactly the same name, you don't even have to list the equality condition, it just does it. Or you could, you could write it like this. You could have also written it as that was fine. It's exactly the same as the previous one. And like I said, in the textbook, they might write it down as, instead of writing it like this, in the textbook, they might write it as department star department location. That's the same thing as writing department join department location. So that is the natural join. So do you have any questions so far on this? So, when you write it like this, you don't have to write the equality condition, which was department dot D number is equal to so it just makes it a lot easier. Okay, so it's 10 o'clock. So just, I'll be continuing with this in the next lecture. And yep, so have a good weekend and I'll see you on Monday.